OCI, Orange County Inspections, is glad to present the QC and QA Professional Seminar, segment number 7. This segment will cover the visual welding equipment, and the following topics are the filler metals, or as also known, the electrode. Now you might be thinking this is not visual equipment, and of course without the electrode the welding could not be done, but for the QC and QA professional there are visual signs you must be alerted for and understand why they happen. Next is the amp voltage meter, and here we will see the how-to, as in the proper setup and techniques. And lastly is the proper usage of the 3 most common used welding gauges that assist with checking the fillet and groove weld. We start with the first topic of this segment, which is one of the key components used in the welding processes, whether it is shielded metal arc welding or flux core arc welding. And that's the filler metal, or also known as the electrodes. As we have seen earlier in this seminar, with this shielded metal arc welding process, the electrode has a solid rod covered by the chemical flux, which will melt with the other 2 plates of material to create the weld joint when the proper current and arc is provided. And with the flux core arc welding process, the use of a wire electrode, which is the opposite of the shielded metal electrode, in that the chemical flux is inside a tubular wire electrode, and this is required due to the wire being manufactured on a round spool. So, we will cover what are the differences between the filler metal specification and classification, and why you, the QC/QA professional, must understand this. The next item is how to identify the markings on both the shielded metal arc welding and flux core arc welding electrodes. As we just mentioned, the 2 processes use completely 2 different manufactured electrodes, and we'll show you how to quickly check the markings for compliance. And lastly is probably the one area where more weld defects are traced back to, and that is the storage of the electrode, whether that is the shielded metal or flux core arc welding processes. I hope by now you are starting to understand there are steps to be followed if you want to have a correct weld joint, and with the filler metal there is no exceptions. So the first step is to understand the difference between the specification and classification meanings. First, the specification is a document that creates the different categories provided by all the different manufacturers out there. What is the specification for filler metals, you may ask? Very good question. Here we see a typical sticker found on a box or can of electro rods from any shop or field project. And here is a call out for the specifications. While looking further, this call out should be familiar to you, the AWS specification A5.18. The second item with the specification is that it establishes the classification for the filler metal. And once again, you may ask, what is the classification of electrode rods? Here we see the AWS classification chart for a few filler metals. And notice, for mild steel, one classification is 6010. Then for mild steel, low alloy, is 9010. And lastly, even for stainless steel, is 15. Now, if these numbers seem like Greek again, we will cover what and how these number callouts work in just a bit. But to close this topic of classification, the classification is a type being used for a group or category of steel material which has been established by testing. And this is for both the shielded metal and flux core arc welding processes. The next topic is the identification of the filler metal, and we start with the shielded metal arc welding process. Here we see a series of numbers and letters, which is the classification marking on the filler metal. This is what the markings look like on some actual electrodes. Now, let's break down how to read and understand each marking. First, the E stands for electrode. Then, the next two numbers, 70, stand for the minimum tensile strength, 70,000 KSI of the metal rod. Now, there is some filler metal where a triple digit number will be listed, and that would mean the same. The number 1 stands for the position that the filler metal can be welded in. A number 1 means all positions, and a number 2 means flat and horizontal positions only. And lastly, the digit number 8, which represents the chemical makeup used around the metal rod, which is called a flux. And as with the tensile strength of the rod, there are dozens of different fluxes that have been established by testing for matching the different material and positions required. And before we leave this topic, if the last numbers are either 5, 6, or 8, it will qualify for low hydrogen electrodes. We now will take a look at the flux core arc welding filler metal. We see a typical callout for the flux core arc welding process, and here is the spools that the wire will come in, and if you are in a high production shop, there could be barrels of wire. So the big difference with shielded metal and flux core arc welding processes are the different style of electrode use. With flux core, the chemical flux is inside a tubular metal rod, which allows it to bend without breaking the coating, and with shielded metal, the coating would break off if the rod is bent. The huge alert here is the sticker location, which is found on the inside of the spool, which states the specification and classification. And remember, with the hustle and excitement of the project, there are times when someone could place the wrong spool in the wrong storage box. Now we break down each symbol found in the classification callout for the flux core arc welding filler metal. The E stands for electrode. Next is the single digit 7, which stands for the minimum tensile strength, KSI, and in this case it would be 70,000 KSI. Now is the number 1, which is the position that this wire can be welded in, and the number 1 stands for welding in all positions, and a 0 means flat and horizontal positions only. We now see the T, which stands for tubular. Remember, with this process, the weld rod is hollow, so that the chemical flux can be placed inside to allow the wire to roll up on the spool. And lastly, it's the number 8, which stands for the type of chemical makeup required for the process, and this has been established by the manufacturer testing. Let's move into a section that causes many rejections within the weld, and many don't even realize why it caused it to begin with, and we are talking about improper storage of the filler metal. First is the shielded metal arc welding filler metal. And one way to store it properly is to bring in brand new electrodes, and the only way to have that is by using a hermetically sealed container. And what does hermetically sealed actually mean? It simply means airtight. Now, we see the cans and notice how many different styles and sizes are available, which can match the production needs. The second way to store electrodes properly, if a brand new can is not used, will be to place the electrode in a proper heated environment at the required time exposure. As per the AWS code, and using our example of the low hydrogen electrode E7018, it can be exposed to the air after the hermetically sealed can is open up to 4 hours. After the 4 hours, the electrodes must be placed in a rod oven that creates heat of 250 degrees until ready for use. And that oven looks like this. Some other important items dealing with storing the electrodes are: you can only rebake the electrode once, so only take what you can use within 4 hours. Next, the electrode can never get wet. If so, they must be discarded. And a little tip for spotting a wet electrode is looking for little round spots along the electrode flux. And lastly, Table 5.1 of the D11 has established the minimum allowable exposure times for low hydrogen electrodes. Plus, there are also provided other tables for the other type of electrodes used throughout the industry. So please remember to review the code and also the manufacturer recommendations, plus the approved project specifications for compliance with the filler metal. Now, let's look at how to store the flux core arc welding wire properly. Here's a typical box and spool of wire used for the flux core process. First is to check that the spools are in a sealed plastic bag or foil package. If the seal is broken, that means the wire is being exposed to the air. Second item is that the flux core arc welding wire, the exposure time is called diffusion hydrogen. Now, in D1.8, it will cover this in detail. So if you tried looking for information in the D11, it will not give an actual time or temperature to store the wire after opening. And that's where the manufacturer will have to be contacted for the established storing requirements. And also, don't forget to have the engineer of record review and approve. The second topic of this segment is the how-to of the amp voltage meter. Here is a typical meter with items such as probes and the carrying case. Other key items of importance with the meter is to have a capacity of 2000 amps, or checking Nelson stud welding will never happen. Next, the meter must be both AC and DC current compatible. And a hole button is very nice for registering the constant moving numbers when viewing both the amps and volts. Plus, the probes will be needed to check the volts. Now we take a look at the functioning parts of an amp voltage meter. Number one is the clamp in, which needs a lever control to open and close the jaws for reading the amps. Number two is the function switch, where the amps or current will be set prior to testing. Number three is the keypad, where the hole button and digital light is found. Number four is the LCD display screen, where the actual numbers of both the amps and volts are shown for reviewing during testing. Number five are the input jacks for the probes. Now, in a perfect world, red means negative and black is positive. But if you reverse the probes, it will still read okay. But just remember to place the probes on the welding equipment matching the setting on the amp. And lastly, the built-in stand and battery are found on the back side. Another important item to deal with, the function switch. Here you set the amps and current prior to testing. On this dial there are symbols, and here are three very important symbols to be aware of. Number one is the two different symbols for the AC and DC currents. Number two, the display hold button for recording the highest reading while testing. And number three is the button for display backlight, and there will always be those times when this is needed. Okay, before we get into the how-to of the meter, we want you to understand this very important rule. You must be qualified to tell others they are wrong. And what I mean by this is, your meter must be calibrated within a 1-year period by a third-party testing laboratory. And here is the sticker that a certified laboratory will place on the instrument when it has been calibrated. And the actual sticker is this simple, but very important for you and your company. Because if you tell someone they are wrong with not complying with the approved PQRs or WPSs, and you are not complying with the code and specifications yourself, there is an old saying in the industry. Can you say back charge? So have your meter calibrated once a year, and when you buy a new meter, please ask if it has been calibrated by a certified third party. Usually the answer will be no, and you will have to pay extra for that step. How to zero out the amp voltage meter. First step, set the meter to the proper current. Second step, push the button to zero the reading on the digital screen. And then your meter is ready to work. How to check the volts using shielded metal arc welding. You will need the probes for testing. Set your meter to read volts. Then secure your meter. Then place one probe on the screw which is located on the twisted connection of the lead, and the other grounded. Take your readings of the volts while welding is in progress. Then record your volts readings. How to check your amps for shielded metal arc welding. Set your meter to read amps. Use the clamp end of your meter within 10 feet of the welder. Take your reading of your amps as welding is in progress. Then log your amp readings when finished. How to use the meter on flux core arc welding. You have two pieces of equipment, the power source and the flux core welding box. With the power source, you must have constant voltage, CV. Here's where the control knob on the power source is located to set the machine to the CV setting. We now will see the wire feed knob that controls the wire speed coming out of the nozzle. Next we will see the CV switch located inside the flux core box. How to check your volts. Set your meter to read volts. Once again, take your probes, place one on the lead and the other on the ground clamp. Take a reading of the volts while welding is in progress. And please remember, watch out for the wire spool spinning. Another option for the negative probe is to place it on the ground coming out of the flux core box. How to check your amps. Set your meter to read amps. Use the clamp end of your meter around the wire, the leading wire. Take a reading of the amps as you clamp it around the welding lead while welding is in progress. Then log both volts and amp readings. The last topic is the proper usage of the welding gauges. Now, there are many gauges offered to you, the QC and QA professional, and they all have their place in the industry. But we will show you how to measure a fillet and groove weld with the three most used gauges. First one are the individual fillet weld gauges. Next is the very versatile bridge cam gauge. And lastly is the best named gauge of all time, the VWAC gauge. How to measure a fillet weld with the individual plate gauge. We have a typical joint, T-joint. You start with measuring the vertical leg. Flip the gauge over and check the horizontal leg length. Then turn the gauge itself over and are able to check the face of the weld. How to measure a fillet weld with a bridge cam gauge. Same principle, but with this gauge it's a little easier to get in position. Put the point on the vertical leg, make the feet flat on the plate and take a reading. Then you would turn the gauge around to measure the horizontal leg. Making sure the feet are flat on the plate. And to measure the face of the weld, flip the gauge over. It has this nice point gauge on it. When the gauge comes in flush with the plates, then you're able to take your reading. And shortest leg equals weld size. How to measure a filler weld, how to measure a groove weld, check the bevel of the plates. Here with the bridge cam gauge, a nice feature, have the legs flat on the piece of plate. Push the sliding face plate to match the bevel. And then you're able to take a reading of the degrees of bevel, which is basically 30 degrees here. Next is check the depth of preparation. You would take the bridge cam gauge, turn it over, and use the point measure. It will give you the depth of preparation. You'd be checking individual passes until completed. And then to check the reinforcement of the groove weld. Put the point of the gauge on top, have the feet come flush to the plate, and then take your reading. We will see how to use the VWAC gauge for checking reinforcement of a groove weld. Same principle, put the point on the weld's face, push it down flush, and take a reading. Notice the little hole there on the right corner, that is for your size of your porosity measurements. And weld side is depth of preparation and reinforcement height. We have come to the end of segment number 7, and let's review the topics we covered. First were filler metals for both the shielded metal and flux core arc welding processes. We learned what the difference between a specification and classification are, what and where to find the classification callout on not only the electrode but also the wire spool. Plus, we covered why improper storage of the filler metal could be causing rejected welds during the production of welding. Second, we covered information on the working parts and, more importantly, the proper setup for testing the weld equipment for both voltage and amperage with the amp voltage meter, while closing with a look at the difference between the industry leaders in weld gauges, the individual plate gauges, bridge cam gauge, and the VWAC gauge. Plus, while showing the proper way to measure items like the filler leg to the reinforcement on a groove. The study material for this segment will have you reading the following: Shielded Metal Arc Welding Filler Metal Guide. Next is the Flux Core Arc Welding Filler Metal Guide. Then we move into the guide for the amp volt meter, and finish with a very well written document from the Oklahoma Department of Transportation about the welding acceptance guidelines. If any questions arise, email us at orangecountyinspections@yahoo.com, then move on to segment number 8 when completed.